Okay, today let's learn the second chapter, Python Language Basics, IPython and Jupyter Notebook. So first you want to import NumPy library and give it an alien name NP. Secondly, you want to define the random seed so that every time you want to generate a random number, you're going to get the same set of numbers instead of different set of numbers. And the third line is pretty much you define the print options. So when you run the cell, there are different ways to run the cell. Either you can click run here, it will run the cell, or you can use some keyboard shortcut listed here. So basically you can use the shift enter, then you are going to run the cell. At the same time, it will select the cell below, or you can simply click Control Enter. It will run the cell, but it will not will pointing you to the cell below. So that's generally how we run the cell. And there are other comments. If you're interested, you can learn by yourself. Yeah, but typically what we use most often is Shift Enter or Control Enter. Let's go back to chapter 2 notebook. Okay, IPython Basics, how to run the IPython share. So second cell you want to run is run this Python code. It actually is Python 3 code. So how to create a Python code. So what you can do is you open the notepad and you type print hello world. Then you save it. Make sure you save it with the extension py instead of the text file. Then you save it. Since I already created in my directory, so basically I'm just going to replace it. So I save it, right? Then I'm going to minimize it. Then I go back to the directory, and you should be able to see this Python code I created here. And let's go back to this cell. So you use the magic command run, then the name of the Python code, and shift enter. It should be able to print hello world, what you just typed in the Python code. Okay, next you want to import NumPy as NP, so it doesn't hurt you import it several times. Yeah, so basically you want to generate a data. So the data actually is a dictionary. So we use these braces to define dictionary. So basically you have the key actually is I. So how do you define I? I is generated in the range of 7. Basically you're going to run 7 iterations of I, which start from 0 to 6 using this range function. And that's I. Then secondly, each time when you run I, you're going to generate a random number. So the output, so if you hit this one, so you're going to get I, which is the key of the dictionary, from 0 to 6, and also you're going to get the value, which is a random number you generated using this random function from the NumPy library. So for dictionary, we are going to talk yet more in chapter 3. Today we are going to just give a brief introduction. So basically, if you type data, you should get the data type of this data you defined, which is a dictionary here. So let's do this. So let's see if you want to define a function. So this is how you define a function. You use the keyword define def, then you give the function name, which is add numbers, and you give the parameters, which is a and b for this function. And here another thing you want to learn is this is just a quotation, is for comments. So anything beside this and this, it's a comment. It's not part of the code. It's just comments, and it's not going to be executed. And the function, what you need is you define the function name and the parameter, and what it's the return, right? So the return is a plus b. That's a simple adding function, right? So if you want to check it, if you want to check the function you just define, so like next you want to run this cell, and the function has been defined. Then if you want to check the function, what's the definition of this function, you just put the function name and adding the question mark. Then click Enter Shift. It will pop up the signature, the name of the function, and the doc string, which is the definition of some function, which is add two numbers together. And the returns is the sum. This is the type of the argument. Yeah, you should be able to see the function, the details. If you using this one, if you use if you put the function name and then put two question mark behind it, following it, you should be able then click on Enter Shift. You should be able to see the source of the function, basically how this function is defined, and it will give you more details. Another thing you may want to do is, let's do this. You can actually load this. What you can do is, okay, let's go to the next one, right? So let's talk about the magic run comment, right? So let's say you want to define another function in the Python, and you want to run it. How should we do it? So this is the function. Let's create this one. Let's go to the notepad, then create a new, then I put this function in that notepad. So this is the function you defined, then we save it. And again, we want to save it as we want to give it a name, IPython script test.py. Make sure the extension, the file extension is py, and not the text file, so it will know it's a Python code. Yeah. So let's save it. And again, I already created one before I record the video, so let's just replace it. So again, let's go back to the directory. You should be able to see the Python code you created just now. Now, you just run this magic command run, then type the name of the Python code you just created. It will run it in the backend. And so if you want to see what is C is, actually it's defining the function. So you should be able to see the value of C. And if you want to check the result, because the final output of this function is the result, you want to check it. Basically, you are going to have this number. Which actually is A plus B divided by C, which is 7.5. So you should get this number. So if you want to load this function, if you want to load the Python function into your notebook, what you can do, you can use another magic command, which is load. And I'm going to just copy this one. And you run this cell. Automatically, it will comment this Python code name in the comment. So I think I didn't mention there are two ways where you can put a comment in the code, right? So if you want to put a single line for the comment, you just use this hash sign. so the code notebook will understand it's a comment. It won't execute it. Or there's another way to do it. You just put this quotation, so the Python's code will also know it's so with in between these three quotations, the Python will know it is just a comment. It won't execute it if you have like more than one line of the comments, right? So after you load it, you're going to have this function loaded into the Python notebook. Yeah. Okay, next one, let's do this. Oh, another magic word command we use often is time it, right? So let's generate a random number, which is 100. So if you want to multiply a by a, so basically if you execute this cell, you should be able to see how much time does it take Python to run this piece of code. And there's a cheat sheet here from this website. You should be able to have a lot of magic comments listed here. If you're interested, you can learn by yourself, but basically what we use the most often is this one, debug. Basically that will enter the interactive debugger. And also another one we use very often is the PDB. It will automatically enter Python debugger after any exception. Another one we use a lot, of course, is this run. If you have already created a Python code, you simply, if you want to run it from the notebook, you can simply use this magic command. And another one we use very often is the timing one. Yeah. So if you're interested, you can go back and refer to this page. So let's go back to the chapter 2. Okay, variables and argument parsing. So how do you define a variable and give it a value? You can just use the equal sign. That's assign a value to a particular variable. So here A is a list which has 3 elements, 1, 2, 3. And you can also just define B equals A. Let's run this code. Let's define B equals A. So let's say A, if you want to append another element to it, does it change B? Yes, it will change B, right? So how it works. Does it change A? Let's see if it changes A or not. Yeah, it changes A as well. So append this function actually is in place change. So we will see some functions in Python which is in place change, which means the underlying object will be changed in place when you execute the code. Some functions is actually is not in place change. So basically when you run this command, the original object, it does not change it. If you want to what you could do is you could reassign the original object plus the function after the function, then assign it to a new object. Yeah, so just be careful with this. So it's not very consistent for which so some functions it's in place changement, some function is not. So you have to see the descriptions of each function to make sure you don't misuse it. Okay, so A, you are going to have 1, 2, 3, 4. So another thing you want to check is A. So A is the object, which is a list, right? So if you want to see what functions you can use to this object, what you can do is you type A point. Then you are going to click on the tab key. So it will show you what functions you can apply to this A object. let's see a append, right? So let's see if what is append function. Let's see the description of this function. If you recall, we just said you just type the function name, then question mark it, then execute the cell, run the cell, then you should be able to see the append. So basically, append is going to append object to the end of the list. That's the append function. Okay. Dynamics reference strong types. Okay, so let's see. A, you're giving the value 5. So what is the type of A? Let's run the cell. Basically, that tells you A is an integer. Okay, A, you want to define it as 4. So what type of A? So now A changed the type to be a string. So for strings, typically what we are going to do, we use the quotation mark, and when the notebook will know it's a string. Okay, so let's add the string 5 with the integer 5. Does it addable? No. So it tells you different types cannot add it together. So let's do another example. Let's make A equals 4.5, B equals 2. Let's print A and B. What's the format? What's the type? So A actually is the type of float. B is in the type of integer. And the float and the integer, they can do mathematical calculations. So what is A divided by B? You should get the number. And let's say if you want to check whether A is the type of each object, one thing is use the type, or you can use this is instance function to check. So for example, A, you define it as 5. You use this function to see if A actually is an integer. Okay, you run it. Okay, that's true. It gives you true value, which means A is an integer, right? So at the same time, another thing you want to see, if you have several code on the same line, you'd better use the semicolon to separate them. Then the Python notebook will know it's a separate code. But we typically don't recommend it. So one line, one code. That's what we typically do. Yeah. So basically, this is asking, okay, is A integer or float? Yeah, let's run this piece of code. Okay, let's just run it. Okay, let's run it. It's true, right? So A is a integer. So it says, okay, why is A either integer or float, right? So let's run B. Is B either integer or float? Actually, B is a float, so it's true. Okay, we covered this. So basically, you type the object, then basically you are click on the tab key. You are going to be able to see what functions you can apply to object A. So let's see A. You define it as a string. Yeah, so basically that's A. And also A, if you want to see the type of the A, the functions you can apply to string function A, string object A, you can just click on tab key, then you are going to see all these functions you can apply, apply to this object A. Okay, duck typing. So basically, you define a function, whether is it iterable. So you are trying to, if it is iterable, right? So if iter this function actually to check if this object put into this function whether it's readable or not. So if it is irreadable, then return true. If it is not irreadable, it will give you an error code. Not irreadable, right? So let's just use this function, apply to a string. A string is defined, always defined as using the single quotation. Yeah. So, okay, string is not immutable. Okay, sorry, I didn't run this piece of code, so it says the function has not been defined. So let's define this function, then run this code. Okay, string is string immutable. Is string iteratable? Yes, it is. Yes. So is this list? So list 1 to 3 is iteratable? Yes, it's true. So is integer actually iteratable? It's just a single element, right? So it's not iteratable. So that's false. Give you false. Okay, so modules sounds like a very big word, but actually it's not that complicated. Module is just a connection of functions when you define the module. So you can actually create a module yourself. So let's do that. So let's open the notepad, right? So let's create a new notepad. So we want to create a module, which is called the sum module, right? So basically it's 3 functions inside this module. So let's put it there. Let's just copy and paste it there. So if you go to this one, okay, so it has 3 functions. One is actually not a function, it's just a pi. It's a pi variable. You define it as 3.14, right? Second is a function, right? This function actually returns x plus 2. So the third function is actually returns the sum of 2 numbers, right? So now you are using these 3 functions, create a new module, and you can save as. So let's name it sum module. Again, you want to use the extension py, so the notebook knows it's a Python code. Yeah, you just save it. I'm going to just replace it. I think since I already created one before I record this video, so let's just save it. Now you create a module, which is called sum module, right? So again, module is just a connection of functions you're putting in the module. So let's go back to here. So you should be able to see this one, sum module, right? So you create this module here, and what you're going to do is you can import this module like you import the NumPy, right? And you want to run some functions here. You just put the library name and the function, which is if you recall, this function is you throw in 5 and you return 5 plus 2. So basically you're going to put actually your result equals library function, and what is your result. So basically your result is 7. And this also you want to import pi. So pi actually you want to put the library name first, then the function or the variable name itself. Then you are running this code, it gives you the number py equals 31415. Yeah. And if you want, similarly, if you want to, another way to import it is you can import the module, then the module, you can import the library, then the library dot function, right? Or another way to do it, you can just use this from some library to import specific function. instead of importing the whole library, you can import just functions you are going to use in the library, right? So basically you are going to run G, record G, actually you throw in A and B. What you get, you are getting the sum of A and B. So basically I'm calling the function G. I'm using the putting the function name, then the parameter 5 and pi. Then I'm going to get the result, the sum of the 5 plus the pi. So I'm going to get the sum of these two. Or another way to do it, yeah, import this library as SMN, right? So you can give it aliens instead of typing some modules every time. You can simply type SMN, point the function, right? So, and also you can, from some module, you can import pi as pi, and you can give the function aliens, right? The G as GF, right? So the code will the code will know, okay, every time you are referring dot gf, that's you are calling the library some module, and you are going to use the function G, right? So let's do this. So again, this function f actually is +2. Whatever you throw in the pi, then it returning pi +2, right? The gf, you are going to sum 6 in the pi, so that's what you get. Okay, let's cover the another topic, which is binary operators and a comparison. What is a binary operators? I also find another website which has a good summary. So it's called Python operator and Boolean's cheat sheet. So if you go to this website, this is very handy, right? So common Python arithmetic operators, which listed here, there's a addition. So 9 plus 2, you get 11. Subtraction and multiplication, division, modulars. This one I want to talk about it. Basically, that's give you the remaining part, right? So 9 divided by 2, you're going to get 4.5. Okay, I need to check this this one. Yeah, modulars. Let's check this one together. What do you get? It retains the remainder of the dividing the left-handed operand by right-hand operand, right? So basically, it gives you the remainder. So my memory is correct. So let's go back to this website to check the operators and explanation. So this is 2 stars. So which is 3 explanation by 2, you're getting 81. So 81, yeah. Okay, floor division. So basically that gives you the integer part of the dividing. Okay. Python assignment operators, equal sign, that's just assigning the value to this variable, and this plus equal sign, which is equal this one. You want to read it yourself. So basically, it is a simplified version of this x plus 2. Similarly, minus equal, that equals x minus 2. And so on and so forth. Python comparison operators. This one you might pay attention. This is a 2 equal sign instead of 1 equal sign. Make sure if you want to compare, that's 2 equal sign. If you want to assign some value to a variable, that's 1 equal sign. That's very easy, common mistake for new learners. Yeah, just make sure you pay attention to that. And the not equal, which is this one, greater than, less than, greater equal to, less equal to. And Boolean values, basically we only have two Boolean values, which is true or false. And logic values, logical operations, yeah, you have or, and or not, right? Okay, this one, when we cover this, we are going to talk about this, but for now I think we're good enough. But this is a very handy cheat sheet. You want to put it very handy so you can refer to it very easily. Yeah, let's go back to this. So basically you can use your Python notebook as a calculator, right? So you run this, it gives you this calculation results. Yeah, same here. So this one is asking you if 5 is less than 2, which is false. Now this one is interesting. The below is a very interesting example. You are assigning A as a list which has 3 elements, 1 to 3, right? So also at the same time you want B equals A. Then if you check B, actually B is also the list 1 to 3, right? So if you want to check C, you are putting a list A. So basically it's going to create a new list in the backend. So when you look at C, although the value is the same, but let's see here, is A is B? That's true, because A and B, they are referring to the same object in the Python, right? Which is the list 1 to 3. But for C, because it's creating a new list, so it will refer to the new list. So basically A is not C, although the value is the same, but A actually is not C. So that's the difference between it's not. It's evaluating whether they are referring to the same object. And this one is evaluating whether the following one. I think I have a lot of codes I have not run yet. Okay, so A is not C. That's true, because they are referring to a different object. And this one is A equal to A. That's asking you whether the value is equal, and that's also true. Yeah, that's very, very interesting. So let me try to explain it using the paint. So basically, let me write it, see if I can write it. Okay. It won't allow me to write it. Okay, let's forget about it. Okay, there's another type, special type in Python notebook, which is called none. So if you assign none to A, you should get nothing return, right? And if you check the type A, you should get the none type. And if you're asking whether A is a none type, that's true. Okay, let me stop here today. Let's continue next time. Thank you for listening.